So, good morning, students. And after a break of, I think, 2 days, 3 days, we are back. And it's good that we did not start this topic. Otherwise, a break would have been not so good. Welcome to this class. This is lecture number 1 in motion in 1D. I guess everyone has heard this term motion in 1D. Yes or no? Okay. Remember, as I always keep on telling you, that whatever we are going to do in 11th standard is the same as your 9th standard. So 9th standard stands for 11th standard and 10th standard stands for 12th standard. So whatever we are going to do in the 11th standard is a repetition of what you had already done in 9th standard. Only, if you imagine, you might be doing a bit more, and some people may call it a bit difficult, but it's not difficult. Physics that we are doing is very simple, as far as I know. The only difficult thing in physics is quantum physics, and no one understands it. We are not going to do quantum physics here. We're going to do very simple things. And if you can do those simple things correctly, I can assure you that you are going to do very well in the exam. Let us start with motion in 1D now. To understand motion, let us first start with what type of motions are there, right? Because to understand motion in 1D, let us see how many things we have to do in the coming time, in the coming days. Motion, when you talk about motion, still I have not told you what is the definition of motion. We'll come to motion the definition, but let us first, as a startup, let us start with what all motion are we going to study. What all types of motion are we going to study? Anyone, any idea? Quick responses. We have wasted a lot of time in the class today. What all type of motion are we going to study? I can probably break it up into 3 branches. Actually, I can only, it's only one type. I can break it into 3 branches, let us say. What are those 3 different types of motion that we are going to study? Tell me, fatapat. Tell me whatever you know. There is no right answer, there is no right or wrong answer. What are the type of motion that you know? Tell me. Fast.
Uniform motion.
Uniform motion.
Non-uniform motion.
Non-uniform motion. Then only 2. I said 3. So only uniform motion and non-uniform motion. Anything else? Anyone else? Think about it. You know, put your thinking cap on. I don't have a cap here. Put my hat is gone. Thinking cap. Put your thinking cap and tell me what are the type of motion that you're going to study. 1 more minute. Anyone saying anything? Types of motion. Think. Physics is simple. It's all about your thinking.
Rotatory motion, sir.
Yes, beta?
Rotatory motion.
Yeah, now we are talking rotatory. Now, if one motion is rotatory, what is the other motion? Give an example of rotatory motion. Right now, you can't see the shade. Whatever is turning about my head.
Example, fan, sir.
Example, fan, sir. Yes, that is rotational motion. Well done. That falls in the second category, rotational. Motion of a fan is rotational. Yes. Then this is second. What is first? First is the very simple one, which we call translation. You understand the meaning of translation? Translation means if you have a block and that block is moving, that is translational motion. If you have a car, the entire motion of the car is translational. I am not talking about the wheels of the car. Translation, rotational. Motion of the fan is rotational. Then we have the third type, and this third type is nothing but, you can call it combined motion. It is a combination of what? Motion of a block is translational. Motion of a fan is rotational. Instead of calling it translational and rotational, we call it pure translation and pure rotation. Pure translation, it does not have any rotation wala part. Pure rotation, it does not have any translation wala part. The third type is the combined one. Combined. When I say combined, what does it mean? It means it's a combination of translational plus rotational. Can you give an example of a motion which is a combined motion of translation and rotation. And that is the most difficult thing that we are going to do in 8th or 9th or 10th chapter, depending on how I classify chapters. Yes, can you give an example of translation plus rotational motion? You do it in everyday life. Combination of translation motion, translation and rotational. Anyone? Combination. Which motion is a combination of both translation and rotation? Anyone? Say. There is no right answer, there is no wrong answer. Answers are not classified on the basis of right or wrong.
Moving bus.
Moving bus. What about the moving bus is a combination of rotation and translation? Moving bus as a whole, I will call it translational. Think about the wheels of the bus, wheels of the car, wheels of your cycle, wheels of your bike, wheels of your whatever. Now when the wheels, this is the wheel, it rotates like this, but at the same time it also moves forward. Do we understand this? It rotates, it also moves forward. Yes or no? Do we understand this?
Sir.
Motion of a wheel on ground, motion of your cycle wheel, motion of your car wheel, that is a combination of translational plus rotation. Do we understand this? Yes or no? No, yes.
Sir.
You understand this? Now see, I am going to give you one more example of a combined motion. Look at this pen. If I throw this pen like this, it's better. If I throw this coin like this, it goes up and it comes down. Goes up, it comes down. This is the case of pure translation. Do we understand this? It goes up, it comes down. This is pure translation. Do we understand this? Now look at this. I spin it. Whee, whee, whee. Do you understand what is happening here? It is going like this, dung 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 dung, and it is also going up, dung 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 dung. Do we understand this? Dung 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 dung. Now that is a combination of what? Combination of what? They say combination of what? It's a combination of dung 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 dung. It is rotating as well as moving up and down. That is the combined motion or a example of translational plus rotation. Do we understand this? Okay, let us move ahead. Now, this combined motion and this rotational motion will come in the chapter of rotation. So let us not worry about it. Let us now concentrate on this translational motion. Now, when I say translation motion, in translational motion, what we are going to do is consider the body as one particle. So we will be dealing with bodies, but we will be considering them as particles. Particles mean, see, when this bus is moving and we consider that the motion of the bus is pure translation. Every point of this bus is also moving in the same way. Yes or no? Everything inside the bus is moving in the same way. Yes or no? So instead of treating bus as this big quantity and draw a big diagram of a bus, we can just draw a point, and that point represents the motion of the bus. Do we understand this? So when I just draw a symbol and I say this is point B or this is bus, and if I just draw it, I don't have to draw the entire bus to describe you, oh, this is a big bus and this is moving. You can just draw a point and describe it. Because the motion of any point on the bus is going to be same. Do we understand this? That motion is known as rotational motion. So that motion is known as translational motion. And in all the questions that we are going to do, we are going to draw bodies at points. Unless and until there is a question where the length is required. Two trains crossing each other, then we will require the length. Otherwise, most of the cases we will be drawing them as points. So that is the motion that we are going to study. Now this translational motion can also be further subdivided into two categories. Two categories. What are those two categories that this translation motion is divided into? Any idea? 2 minutes, fatafat, give me. This translation motion is divided into two categories, two types. Fatapat. I don't have time. The first one is known as rectilinear motion. Have you heard about rectilinear motion? This rectilinear motion is also known as motion in a straight line or motion in one dimension. These are all names of the same thing, rectilinear motion. Do we understand this? Anything moving in a straight line, that motion is rectilinear motion or motion in a straight line or motion in one dimension. Let us see. If a body is moving like this, along x-axis, like this motion will be motion in one dimension. Do we understand this? Or rectilinear motion? If the body is moving like this, up, down, this is a motion in a straight line. Do we understand this? Now tell me, if the body is, oops, why can't I draw a bloody straight line? Okay. If the body is moving like this, is it motion in 1D or is it motion in 2D? Because if I look at it in this way, if this is your x-axis and this is your y-axis, this looks like a motion in 2D, yes or no? But it is not motion in 2D. It is always, because this particle is moving in a straight line, it is always motion in one dimension or motion in a straight line. Do we understand this? Raise hand will give you more confidence. So all these are examples of motion in one dimension or motion in a straight line. Anything moving in a straight line. And we will think of them as point objects. Now, if this is rectilinear motion, then what the other type of motion is known as? The other type of motion is known as curvilinear. The other type of motion is known as curvilinear. Now, as soon as this word curvilinear comes, you start drawing curves in your head, and that is correct. If the body moves like this, that is curvilinear. Now, even this curvilinear motion can be further subdivided for better understanding into two types, which is motion in a plane, a body moving in a plane. Right now, I'm writing something on my tablet. If I move my pen on the tablet, it is moving on a plane. This is motion in 2D. Do we understand this? Instead of calling it motion in a plane, you can also call it motion in 2 dimension. Whatever I'm doing right now on the board is motion in 2 dimension. It's on a plane. Do we understand this? It's on a plane. Plane is the surface. Plane is the 2-dimensional body. Do we understand this? Then if one type of motion or curvilinear motion is known as motion in a plane, what the next and the last type is known as? That is known as motion in space, or we say motion in 3 dimensions. Do we understand this? Motion in space. Think of motion of a fly. It can go anywhere in space, 3 dimension. This is motion in 3 dimension or motion in space. Which is the simplest of all these? 1D, 2D, 3D. Which is the simplest of all these? And from where should we start our journey of understanding motion? And the answer is pretty simple. The simplest motion is? Which one? 1D is one, 2D is second, and 3D is third. Which is the simplest motion to start our life with? 1, 2, 3, which one? And the simplest motion is motion in 1 dimension or motion in a straight line. That is correct. And that is what we are going to start our life with. Motion in 1 dimension or motion in a straight line. So welcome. And now officially we start our journey in physics. Motion in 1 dimension or motion in a straight line. Remember, we are going to confine ourselves to this motion, straight line. This one, this one, or whatever one, whenever, unless and until it is moving in a straight line. That is our heading: motion in one dimension or motion in a straight line. But before we understand any motion, it is very important for us to understand it from the very basic part. And the very basic part is, how are we going to study motion? Now, whenever we do some job, for example, right now I'm teaching you. Now, to teach you, I need certain tools. Without those tools, I can't teach you. The most important tool is this meeting that is happening. And one of those tools is that camera from which you can see my face. The other tool is a laptop, which is connecting me to you. The other thing is this is a whiteboard on which I draw your stuff. Then this is pen. Without this pen, I will not be able to draw. I will just be able to make all sorts of funny gestures. So I need some tools so that I can take your class. You also need tools to study in the class. You need tool to come from your home to this place. Then you need your pencil box, copy, pen, and all those things. Now, when we have to understand motion, we also need some tools. Without those tools, we cannot understand motion. So, what are the tools that are required to understand motion? Before understanding anything, we need proper tools. I'm a marine engineer, so without tools, a marine engineer is as good as a common human being. Because if I have to open a nut or a bolt, I need a spanner. I cannot open a nut or a bolt with my hands. So that doesn't work. So any engineer, any doctor, without your stethoscope, you will not be able to gauge whether the patient is alive or dead. Alive or dead, you can tell. You will not be able to do anything. If you don't have medicines and you have found out that you have got this bimari, my dear friend, but I don't have medicine, so I can't help you, or go and enjoy your life. You can't do that. We need tools. What are the tools that we need to understand motion? Anyone? First, what are the tools we need to understand motion? The first tool, and the very important tool, is the observer, who is going to observe the motion. If no one is seeing the motion, I mean, there is nothing that you can find out. No one is there to see the motion. Someone must be there to see the motion. Your observer. You need an observer who is going to understand the motion, see the motion. Now, this observer can be thought of in a different way as well. Now, this observer can be sitting on a chair right now, on ground like this. He can be in a moving bus. He can be in a moving train. He can be on a bike. He can be on a car. He can be on a plane. So, depending on where the observer is, he will observe the motion differently. Do we understand this? Yes or no? If right now I am the observer, this pen is stationary to me. But is it stationary to everyone in the universe? No. Someone in the International Space Station might see it rotating with the Earth and moving around with the Earth. So for him, it is not stationary. That means motion depends on from where the observer is watching the motion, my dear friends. That thing from where he is watching the motion is known as what? From where the motion is observed is known as your reference frame. And this is the most important aspect of understanding the motion. Where is your reference frame? From where are you observing the motion? Without a reference frame, my dear friend, everything is pure fantasy. Now, when you have a reference frame, now whenever we talk about reference frame, and let us restrict ourselves to two-dimensional motion, x and y, you must have some reference axis, some x-axis, some y-axis, and you must have some origin O from where you are going to understand, okay, where is everything. For example, if I have to tell you right now, there is a wall in front of me, where is that wall? How do I tell you? I need to tell you where is my origin, which is my x-axis, which is my y-axis. Right now, if I ask you, where are you? You'll say, sir, we are in Hyderabad. Okay, where is Hyderabad? In India. Where is India? So you need some reference from where you can tell everyone where your location is. And we normally tell the location of any point on Earth by something known as the GPS coordinates. Have you heard about GPS coordinates? You all have them on your mobile phone, right? Yes or no? You share your location live on your Google thing and all that. What does it tell you? It just tells you the GPS location. GPS. So this is your GPS. X and Y is your GPS. And you must have your origin. Now let us say if an object is here, this, let us say A is the object. Now, if you know where is the origin, you can tell everyone, okay, this is my origin. Point A has got x coordinates of this much, y coordinates of this much, and then you can find out the position of the object A. Do we understand this, yes or no? So, what is the most important thing here is that you must have a reference frame. Without reference frame, nothing makes sense. Do we understand this? Without reference frame, nothing makes sense. So that is the most important thing about your study. If you want to study something, you need a reference frame. Now let us say I change my reference frame. If I change my reference frame and now I have drawn a different reference frame, now this different reference frame has a different x-axis, different y-axis, x dash y dash, and let me call the origin as o dash. Now remember, the point A is still where it was. It has not changed anything. But when I tell you the position of point A now from this blue reference frame, your blue origin, in terms of x and y coordinates, the position will look different. Yes or no? But still, my dear friends, looking at the yellow origin or looking at the blue origin, the point may look different position wise, coordinate wise, but actually we are referring to the same point. That means everything that we are going to do depends on your reference frame, and this is the most important aspect that you must understand here in motion, anywhere in physics, that the most important aspect is the reference frame. Depending on your reference frame, the same point may start to look different. Do we understand this? So reference frame is the most important thing. Yes or no? No, yes. Say yes or no. Do you understand this? Reference frame is the most important thing. Then the third thing, everyone is there with me? Everyone is noting this down? Yes or no? This is a yes. This is a no, sir. We don't have time for all this. Okay, we have time. Great. The third thing that we need is a timing device. Now we must, if I ask you this question and most of you cannot talk just because the mic is not working, we need a timing device. Now let us say, if I ask you this question, we live in the world that we live in, the universe that we live in, how many dimensions it has? Most of you will say that, sir, we live in a three-dimensional world. X-axis, y-axis, z-axis. Well, if I have to tell you the position of this point, my dear friends, in space, position of point A, green one, I have to tell you its x coordinate. So first of all, I have to tell you where my origin is. Let us move beyond that. Where that origin is. Let us move beyond it, because that is a reference frame. Without reference frame, nothing makes sense. Now, if I have a reference frame and if someone asks me, tell me the position of this point A, you have to tell me is x-axis, yes or no? You have to tell me is y coordinate, and you have to tell me z coordinate. These three are position of the particle in space. Space. The wonderful place, space. This is the position of the particle in space, where the particle is located in space. But there is one more important thing that you must remember to tell the position of any particle in space. We need 3 dimensions of space, and we need one more dimension. And that is the dimension of time. At what time it is there at that point? Because it is not going to remain there forever. With time, everything changes. Right now, wherever we are rotating with Earth, and the Earth is also revolving around the sun. So you can tell the position of yourself in space. But if an alien has to come, he knows your space coordinate. Okay, you are here. He will come there, but you may not be there, because till that time Earth would have gone somewhere else. You say, oh God, what has happened? Time is the fourth dimension that we must all worry about, and we must tell everyone about time. For example, 2 people are supposed to meet, A and B. A is supposed to meet B. A tells B, okay, let's meet at CCD. B says, okay, let's meet at CCD. A says, fine. B says, fine. Let's meet at CCD. They all go. They both go. They have found out the location of the CCD. Okay, this CCD at this place. A comes there, waits for some time. It does not see B. He said, okay, B has made fun of me. Let go. Let me go. Then B comes here. He sees A is not there. He says, okay, A has made fun of me. He goes away. Why they could not meet? They had fixed up a position. We will meet at CCD. Why they could not meet? Well, the simple answer is they did not tell each other what time they are supposed to meet. Time is the fourth dimension. This class right now is happening. You know the place. For you, you have to come to your class and sit. I have to come to my room and sit. Will the class ever happen? Will you be able to attend the class, or will I be able to take your class? No, unless until I tell you the what? Time. Time is the fourth dimension, and therefore we need a timing device to steady motion. Without this timing device, again, anything that does not make any sense. So if we have all these three things in our hands, my dear friends, and these are not very hard to get, then we are in a state to understand or steady motion or rest. Do we understand this? Okay. Now let us suppose that we have a timing device, we have an observer, we have a reference frame. Now we have the tools to now start studying rest or motion. Now, to understand anything, whether it is rest or whether it is motion, we have to understand what the definition is. So the first definition, and this chapter is about definition. If you understand them correctly, 90% of the chapter is done at that point. Maybe 98%. Only 2% are the rest of the things. First definition that we are going to encounter, my dear friends, is the motion. Is the definition of rest. What do you mean by rest? Yes, now I'll give you time, 1 second, 1 minute, to tell me what is the definition of rest. What do you mean by rest? Yes, tell me, everyone. I hope there is a mic available and that mic does work. Mic is the tool that you are going to use to attend this class. Yes, anyone? You can tell me the definition of rest. What do you mean by rest? Do it fast. What do you mean by rest? That's the first definition. Rest. What do you mean by rest? Has anyone speak? No one can speak. Okay. I can only see one class, so I will ask you to unmute. Unmute yourself and then speak and tell me what do you mean by rest. Fatafat, because the other class seems to have been lost in space. There is a series. There was a film, Lost in Space, where they go and they get lost. There was a series also, Lost in Space. This family, they are in a spacecraft and they land up nowhere. Lost in space. Yes, tell me, what do you mean by rest? We can't be lost in space. Right now we are motion in 1D. We are just moving in a straight line. Yes. What do you mean by motion? Now, what do you mean by rest? Fatafat, we don't have the entire time. We don't have time to eternity that I can wait and sir, wait. I'm thinking about rest. Anyone knows what is rest? Tell me the definition. Say, don't be shy. There is no right and no wrong. Why is everyone looking back? You have made notes before my lecture. That is great. But even that doesn't work if you don't remember them, bacha. Okay, what do you mean by rest? Again, try. Jaldi, 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 jaldi. Jaldi means quick. Quick means fast. Fast means ASAP. You are more used to all this short form ASAP, as soon as possible. What is rest? Let's say,
if a body does not change its position.
If a body does not change its position. Well done. So, this pen, is it at rest or is it moving? This pen, you can see this pen, right? Is it at rest or is it moving?
Rest.
Rest, pakka?
Yes, sir.
Well done. Well, there was a gentleman by the name of Sir Albert Einstein. Heard about his name? Heard his name? Sir Albert Einstein? Is it a yes? Is it a no? Sir, who is Einstein? We don't know him, right? Let him go to hell. Have you heard his name? Yes? He once said, very famously, that everything in this universe is relative. Everything that we see in this wonderful universe, only 4% of that which we see, 96% is dark matter, we don't know anything about it. So 4% of the universe that we see, everything that we see in that universe is relative. What do you mean by relative? Relative does not mean that I am the father and I am the son and I am related to each other. No, does not mean that way. Everything in this universe is relative. That means whenever we talk about something, we cannot give you an absolute term for it. Everything that we see, everything that we observe, everything that we experience is relative. We compare it to something else. I am very sad today. That means I am comparing it to some day where I was more happy. I am very happy today. Comparing it to some day where I was more sad. Everything in this universe is relative. It depends on from where you are seeing it. This thing that I have in your hand. You see geometrical. You see a geometrical figure, right? It's a rectangle. Do you see a rectangle here? Yes or no? It's a rectangle. Yes or no?
Yes, sir.
That's absolutely true. Well, from where you see, this is a rectangle which has got a length. If I call this as length and a breadth. Great. Now, if someone sees it from here, from this side, what does it see? He again sees a rectangle, but the rectangle looks like this. Yes or no? Is he looking at the same thing or he is looking at a different thing? He is looking at the same thing, but he sees it from a different angle. Someone sitting on top, God, you see this? Oh, you all fools. See, it is a rectangle, but it is like this. Now, who is seeing the right thing? You, that person, or the Almighty? Who sees, oh, fools, it is this. We are referring to the same thing, but it looks different. Why does it look different? Because we are seeing it from different angles. We are seeing it from different reference frames. Do we understand this? Everything is relative. That means everything depends on your reference. Without reference frame, nothing makes sense. For you, this pen is at rest. But there is no absolute rest. There is no absolute motion. Because for someone, which may not be you, it might be looking in motion. For example, now a cat starts to walk. Now when this cat or rat or whatever, mouse, when he sees this pen, he does not see this pen in at rest. He sees it moving backwards. Yes or no? So for him, it is in motion. For you, this pen is definitely at rest. No one in the universe can say that it is in motion. No, beta. There is no right thing, there is no wrong thing. For this mouse, that pen is moving backwards. For a person who is sitting in the International Space Station, this motion is very complicated because he is rotating with a and that also is moving around the sun. So this pen is in a different type of a motion. Nothing is absolute. Everything is relative. Rest and motion are relative terms. So it depends on your what? Rest and motion depends on what? Use your head. Rest and motion depends on your reference frame. So therefore, whenever you say the definition of rest or motion, one thing must be very clear in that, the meaning of reference frame. Now again rephrase your definition. What is rest? A body is said to be at rest when? A body is said to be at rest. The most important thing you have to add here, with respect to, RT means with respect to a given RF. What do you mean by this RF?
Reference frame.
Well done. So this is the most important aspect that I have added. That gives this definition the correct meaning. A body is said to be at rest with respect to a given reference frame when, now you can add your definition, when it does not change what? Its position with respect to the given reference frame. Do we understand this? So I've added just one term here that gives you the definition, correct definition, incorporating everything that we have studied. That the most important thing is reference frame. Do we understand this? Now, if you have understood the definition of rest, then I will give you 1 minute to tell me what will be the definition of motion and 1 minute to write it. I will not be writing it for you. Yes, tell me what will be the definition of motion now.
If a body changes its position.
Shake the complete definition. Why you are so busily in talking? Speak that thing, because remember, beta, what we speak is what we understand. If you say something only half, you only understand that half, and you probably have missed the most important point there. So again, try. And use your brain, and it will start to work. Brain is one thing that the more you use, the better it becomes. Only thing in this universe that improves with the usage. The tire, it goes bad when it is used. My laptop, when it was new, it was jump, 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 jump. Now it is tum, 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 tum. With use, the performance is getting down. The battery of this, my screen has gone. I'm going to change this phone. With time, this screen has gone. They see it does not open now. It hangs. With time, everything degrades. Brain does not. What is the definition of motion? Fatafat. Right. Motion of the definition of rest is given. Tell me the definition of motion. Fatafat. A body is. Start. A body is.
A body is said to be motion with respect to time.
Try again.
A body is said to be motion.
Said to be in motion. Hai na?
In motion.
English has to be correct. Yes.
With respect to reference frame. When it does change
Its position.
Okay.
Change its position.
So what we got to do? A body is said to be, instead of at rest, what should come?
in motion.
In motion. Again, with respect to a given reference frame, when it, in place of does not, what will come?
When it changes its position.
With respect to the given reference frame, to take out that point that is in pink, instead of at rest, put a body is said to be in motion with respect to a given reference frame when it changes its position with respect to the given reference frame. I give you 1 minute to do that. So remember, once you understand one thing, the rest of the things will follow, and I'll prove it to you. Understand one thing, bacha, and the rest of the definitions will be following on a straight path. They will not deviate. If you understand one definition, the other definition will follow. And that's how simple the physics is, because the most difficult part of physics is quantum physics, and no one understands. I certainly don't. And we are not going to study that. So God has saved us. Have you written the definition of motion, my dear friends? Yes or no? I'm not going to write it. You have to write it, because you'll have to use your brains and your hands and your handwriting. Everything will improve. Time. Written? Let's say yes or no. Okay, I guess everyone has written the definition, yes or no? Well then, that takes me to an end of this session. The session began late. I request everyone to come to the class before time, because time is one thing that we don't have. control over is a luxury that we don't have. Time lost is time lost, whether it is in relative terms or it is in absolute terms. Remember what Sir Albert Einstein said? Everything in this universe is relative. Rest and motion are relative terms. That means rest and motion depends on the most important thing, and that important thing is reference frame, my dear friends. That is what we have done today. We have seen what is rest, what is motion. We have seen what do you mean by reference frame. We've seen that that is the most important thing that is going to come. We'll continue our discussion in the next class. We'll be dealing with the other terms that are going to come. And terms are going to come, dub, every word. Distance, displacement, velocity, speed, acceleration. These are the terms that are going to come. Understand the definition of one, and everything else will follow. But if you understand that definition wrongly, everything else becomes dark matter. No one can see that. Only 4% of the universe is what we see. 96% is dark matter, and we don't understand it. So we will try to make the facts not dark but light. We'll continue in the next class. Please make your notes. Please write the definition very, very correctly. You may not use English. That's not our mother tongue anyways. You can use your own language. Hindi is my mother tongue. I'm not very good at it in writing, but I'm very good at it in speaking terms. You can write it in any language that you feel comfortable with, but I hope you understand what is written on the board in English. Yes or no? Convert it into your language, whatever language you prefer. Every language is Indian, and I love all of them. I may not be able to speak them. Write in your own language, understand what is terms, and highlight the important point that this is the most important point here. So I'll see you in the next class. Take care. May God bless you all. Bye bye, bacha. Take care.